All right, hello everyone. The purpose of this video is to go over some of the prerequisite skills we need to know before doing section 1.6. So we're going to talk about solving for variables in terms of other variables, because that's something that'll come up in what we learn in section 1.6. Okay? So we're going to start with this first one. So we have the equation y equals 2x minus 5, and we just solve it for the variable x. Now, because we are solving for variables in terms of other variables, one thing to keep in mind here is at the end, we want our answer to look something like x equals, but what it equals over here will not just be a number. It'll be a number with a variable, maybe some operations and some other things going on. Okay, so that's what we mean when we say solve for variables in terms of other variables. All right. Okay, so let's set this up so we can work with it. So the y equals 2x minus 5. And again, we need to solve for the variable x, which means we need to isolate the x. And as we're doing this, I'm going to have a parallel problem over here that we're going to work on. So 3 equals 2x minus 5 is a way to kind of model what we do with the left-hand equation. Okay. So in the 3 equals 2x minus 5 problem, if we're going to solve for x there, well, first of all, we know we have to use opposite operations. And we need to isolate the x. And we know that we would start with adding 5 to both sides. So we'd add 5 here and add 5 here. And the reason we do that is because on that right-hand side, oops, the negative 5 and the positive 5 will cancel out. On the left-hand side, we have 3 plus 5, which is 8, equals 2x. Okay. Well, with our left-hand equation, we can do a similar thing. We can add 5 to both sides. On the right-hand side, the negative 5 and positive 5 will still cancel out. And on the left-hand side, we have y plus 5. Now, be very careful here. Y plus 5 is not the same as what I'm about to write. It is not the same as 5y. Okay? Those are not the same as y plus 5. 5y means y times 5, and here we're not doing that, we're adding. Okay? So rather than having y plus 5, or sorry, 5y, we, because the y and the 5 are not like terms, okay, we can't combine them. We'll just leave that as y plus 5 equals 2y, or 2x, excuse me. And then going back to our right-hand equation over there, to finish solving for x, we would divide by 2 on both sides. So we'll end up with just x equals 4 there on the right. We do a similar thing on the left-hand equation, so divide by 2 here. When we divide by 2 on the left-hand side, we need to make sure we divide everything by 2. Okay, so not just the y, or not just the 5, we divide everything by 2. Okay? And again, the 2's there will cancel. And so our answer for x will be x equals what we have left on the left-hand side, or we've come up with, which is y plus 5 over 2. Okay? And that would be our answer for x. All right. Let's look at the next one. So now we have v equals 2 over t. And we need to isolate the variable t in this case. So let's set this up. We have v equals 2 over t. And notice that one issue we run into here is that the t is in the denominator of our that fraction on the right-hand side, right? So we need to figure out how we're going to deal with that. Well, recall that if you have something like 2 over t, that is the same as 2 divided by t. And what would be helpful here is to do some sort of an opposite operation to get the t out of the denominator. So the way we can do that is if on the right-hand side we multiply by, this has to be multiplied by t, And whatever we do to one side, we have to do the other, so we'll multiply by t on the left-hand side. On the right-hand side, that green t there, we can write as t over 1. Notice now what we have on that right-hand side is a t in the numerator and a t in the denominator, so those can cancel because everything's being multiplied. And on the right-hand side, then we would be left with 2 over 1, which is just 2. On the left-hand side, we have the t times the v, and since those are two different variables, we can't do a whole lot with those, so leave those as t times v. And then we can solve for t here by getting rid of the thing that's with it, which is the v. And notice the v is being multiplied, so we can do opposite operations and divide by v on both sides. Okay, so these v's will cancel out. And when we do that, we will end up with t equals 2 over v. Okay, and that would be our equation for t now. Cool, one more. So let's look at the last one there. So b equals s minus 2 quantity squared minus 1. And here we need to isolate the s, which means get the s alone. And notice there's kind of a slew of things here surrounding that s, right? We have the minus 2, the squared, and then the minus 1. So in an instance like this, to isolate our variable, we're going to start with the thing that's furthest away from it, or kind of the most operations away. In this case, that would be the minus 1. So we'll start by moving that to the left-hand side, so we'll add 1 to both sides. When we do that, the minus 1 and plus 1 on the right cancel. On the left, we have a b plus 1, but as before, we can't add those two, so we'll do b plus 1 there equals s minus 2 squared. And it may be really tempting at this point to try to add 2 to both sides, but notice we can't do that because that minus 2 is inside of those parentheses with the s, and all of that is being squared. So what are we going to do instead? Well, we need to undo the squared somehow. And as we've been talking about, to undo these things, we have to do the opposite of the squared, which is the square root. So do the square root on the right, or on the right, yep, do a square root on the left. Recall also that when you take a square root, when you're solving, you end up with two answers, and you show that by doing a plus or minus, okay? So on that left-hand side, we've taken a plus or minus square root. So on the right-hand side, the squared and the square root will cancel out. We're left with just s minus 2. On the left-hand side right now, we have the plus or minus square root of b plus 1. And then we were almost done at this point. We just need to finish isolating the s. So we have the minus 2 there, so we need to add 2 now to both sides. And again, the minus 2 and the plus 2 there will cancel, but we need to be very careful about this next step. Okay? So we cannot add the 1 and the 2. Okay, so we can't get like a square root of b plus 3. And the reason for that is that the 1 is underneath the root and the 2 is not. So in this case, we can't combine them, so what we end up with for s then is that s equals plus or minus square root of b plus 1, all under the root, and the plus 2 on the outside. Okay? And that would be our final answer there. All right, thanks for watching. That's all for now.